Good morning, Anne Mary.
Good morning, Dr. McBride.
Any questions from your homework as you've been working through them?
So far, no.
Good deal. Did you try and retake chapter 11 again to see if it was open and working for you?
No, I didn't try.
All right. It should allow you up to, I think, 5 tries.
Okay.
All right, here's the first question. While we wait for everybody else to join us, tell me which one of these are spontaneous?
The first one. Would it be the first 3 and then the last 2?
Like that? First 3 and last 2?
Yes.
And why would you say that?
Because spontaneous are negative.
Spontaneous are negative. What's the delta G of the third one?
Oh, I thought it was a negative. Is the first 2 negative?
The first 2 are negative, yes. Sorry, I don't know how to make the screen bigger.
And is there a negative for the last one?
The last one is negative 820. So it's negative 1137, negative 91.1, positive 55.6, positive 457, positive 90.8, and negative 820.
So it would be the first 2 and the last one.
All right, perfect. Had you got to that one yet?
No.
All right, this is one we've talked about before also. If delta H is positive and delta S is positive, delta H is positive and delta S is negative, delta H is negative and delta S is positive, and then negative, negative. So if a liquid is going to a solid, what can you tell me about delta H?
So would it be like delta H and delta S is positive and delta G would be always negative?
Okay, I'm writing these down real quick. All right, here we go. All right, if we're going from a liquid to a solid, what can you tell me about delta H? Is it exothermic or endothermic? Liquid, water going to ice. Does it absorb energy or does it release energy?
It absorbs energy.
All right, so for water to freeze, so think of yourself. If you absorb energy, do you get warmer or colder?
Warmer.
All right, so will a liquid, the liquid gets warmer, will it freeze?
No.
So what does the liquid have to do to freeze?
To release energy.
Right, so if you lose energy, then you freeze. So if you lose energy, delta H would be what sign?
Negative.
All right, and as you go from a liquid to solid, are you getting more ordered or more disordered?
More ordered.
So is that positive or negative?
Positive.
So more ordered, and this one is exothermic. All right, what happens? You go from a gas to a solid. You losing energy or gaining energy? Gas to a solid.
Would gas be losing energy?
Right? So negative, exothermic. Is it becoming more ordered or more disordered?
More ordered.
So that would be positive or negative.
Positive.
Okay, how about a solid to a gas? So ice evaporating.
Would it release energy?
So for ice to melt, would it gain or lose energy?
Lose.
All right. So think of an ice cube. If it loses energy, it's going to get colder. If it gains heat, it's going to get warmer. Or think of yourself. If you gain heat from a fire, you get warmer. If you lose heat, then you get colder. So to go from a solid to a gas, does it need to get warmer or colder?
Warmer.
So is it going to absorb heat to get warmer or will it release heat to get warmer?
Absorb.
Right. So is that positive or negative?
Positive.
Right. And so that one would be endothermic. Now, is this more ordered or more disordered?
More disorder.
So is that positive or negative?
Negative.
So, okay. And from a gas to a liquid. Is it going to gain energy or lose energy to go from a gas cooling down to a liquid?
Loose.
Right, so it'll lose energy, so exothermic. And is it becoming more ordered or more disordered?
More order.
Okay, liquid to a gas. Gain or lose energy? Water turning into a gas.
Would it gain energy?
And is that more ordered or more disordered?
More disorder.
And a solid to a liquid.
Would it be positive?
So it's going to lose or gain energy. Is it going to gain energy?
Yes.
More ordered or more disordered?
More disorder.
All right. So these are good, except for the sign of delta S. When it becomes more ordered. So entropy is, what is the definition of entropy?
It's a measure of disorder.
Okay, so measure of disorder. So the higher it is, the more disordered it is. So the greater the number, the more disordered it is. So if it's disordered, it's going to be positive. And if it's ordered, it's going to be negative. That makes sense?
Yes.
Because positive numbers are larger than negative numbers, and entropy is disorder. So the higher, the more disordered it is, the more positive it is. So if it's ordered, it's going to be negative. If it's disordered, it's going to be positive. All right, let's go back to that problem. So we had delta H and delta S both positive. That was solid to a liquid. And gas. And you had solid to gas. And then you had delta H and delta S both negative, was liquid to solid, gas to solid, and gas to liquid. So it basically just says the ones that were both negative, liquid to solid, gas to solid, and gas to liquid. And then the ones that were both positives were the others. All right, we're gonna try another problem here. Welcome, Jennifer.
Hello.
All right, here's our new problem. It says delta G equals delta H minus T delta S. That's our basic equation. And at equilibrium, we know delta G is 0. And the equilibrium constant is equal to 1. So at equilibrium, G is 0, K is 1. So we're going to look at the boiling point of this substance. It has a heat of vaporization of 31.09 kilojoules per mole and an entropy of vaporization of 90.37 joules per Kelvin mole. And I want to find the boiling point. So to do this problem, we're going to use delta G equals delta H minus T delta S. I know that delta G at equilibrium is 0. So I'm going to put in 0 for delta G. Delta H is 31.09 kilojoules per mole minus temperature. It says find the boiling point, so I don't know the temperature. So I'm going to put T. And delta S, what do I put in for delta S?
90.37 joules per Kelvin mole.
All right, so you'll notice that H is kilojoules, S is joules. So I need both of those to be the same units.
0.09037.
All right, so that's what you have to be really careful with all of these problems, is make sure you change joules into kilojoules. All right, now what do I do? This is algebra time.
Divide by T.
Think of it as 0 equals 5 minus 15 T. So I think this would be 0 equals 5 minus 15 T. How would you solve for T?
You're going to add T to both sides. You're going to add the
So do what?
add T to both sides.
So
The
add T.
15T.
If I add T, just one T?
Sorry, the 15T.
All right, so add 15 T to both sides.
Yep.
So that would give me 15 T equals 5. Then what would I do?
Divide by 15.
Okay. Same pattern. What are you going to do to this side?
Plus T to both sides.
Do what?
Add T to both sides plus T.
Plus what?
One T. Oh no, sorry. It's the parentheses.
Yeah, so it's 0.09037 T. Just think of the T on this side instead of on the left, put it on the right. So 0.09037 T. So you have 0.09037 T equals 31.09. Because these negative and positive are going to cancel out, just like negative 15, positive 15 went to 0, positive 0.09, negative 0.09 t's are going to go to 0. So this is 0.09037 t equals 31.09. Now how do I solve for t?
Divide by 0.09.
This is why you're taking that algebra, Jennifer.
Yes,
So you can-
indeed.
You can do your chemistry. Right, then it's just doing the division.
$344.03.
And the units are going to be,
Kilojoules per mole.
all right, so
Kilojoules per Kelvin mole.
right, the 31.09 is kilojoules per mole. The 0.09 is kilojoules per mole Kelvin.
Would it be just Kelvin?
Right, because the kilojoules per mole are going to cancel, just leaving you in Kelvin. Now, how do I change that to Celsius?
Subtract 273.
Right. So I got 71.03 degrees Celsius. All right, does this whole process make sense?
Yes.
And Mary, questions?
No.
So if you saw this one on a test where it said at equilibrium, delta G equals 0, K equals 1, gives you the vaporization for enthalpy and entropy. Says find the boiling point. You're going to put 0 in for delta G, put your numbers in, make sure that your delta S gets converted into kilojoules. Then it's algebra time. So this one was problem 12 on your homework. So gives you different numbers every time. That was the problem. So you're good with that one, or you want to try another one?
Let's try one more.
All right. I'm going to write this information down, then we'll go to the whiteboard. So delta H is 49.28. Delta S, 56.57. What is the boiling point? All right, you two tell me what to do.
Do you use the same equation as the last question?
So what is the equation?
Delta G equals delta H minus T delta S.
All right, that's good. You have to tell me every step on this problem. Or do you want to take time to do it and give me your answer?
So you plug in 49.28 kilojoules per mole for delta H.
Do you both have a calculator?
Yeah.
Yes.
All right. Okay, I'm giving you 3 minutes to do it. All right, let me know when you're done.
I have an answer. I got 727 degrees Celsius.
All right, and Mary?
I'm checking my answer because I feel like I went wrong somewhere.
What'd you get?
So for the Kelvin, I got 871.13.
All right, this is what I came up with. Because it's boiling point, we're at equilibrium, so delta G is 0. And we have 49.28 is delta H. And welcome Levi, Preston, Kendra, Grace.
Oh, Mr. McBride.
Yes.
So I don't know if it's on like for other people, but like the Canvas deal is like locking people out, like saying something about security then or something like that. So Grace is here JC's here and Kai's here too.
Okay, so all of you are here?
Yeah, I just didn't have enough room to put all of them on my screen.
Okay, sounds good.
All right.
All right. So we are doing the problem number 12 on the homework, which it says the boiling point is, we're trying to find the boiling point. And so when you find the boiling point, we know that it's at equilibrium. So delta G is automatically 0. So we put 0 in for delta G. We put our number in for delta H minus T, we're trying to find the temperature. And S has to be converted into kilojoules. So 0.05657 kilojoules. And then that gives us the 49.28 minus 0.05657 T. And then we have to solve for T. So in this case, I just subtracted 49.28 from both sides. Which gives me negative 49.28 on the left side equals a negative 0.05657 T. And then to solve for T, we divide both sides by the negative 0.05657. Then I got T equals 871. And then subtract 273 gives us our Celsius temperature. So Jennifer, did you see what you did wrong?
Yes, I did, and I have that same answer now.
Okay, great. I think you got that one, or you want to try another one?
I'm good now.
All right, Levi, Preston, Kendrick, JC, Grace. Did you have any homework questions that?
No.
All right, we're gonna try this one then. So what is the value of K for this aqueous reaction at 298 Kelvin? So we have A plus B goes to C plus D, delta G equals 26.59 kilojoules per mole. So Kai, is this spontaneous or non-spontaneous? Delta G is 26.59.
Wait, can you say that again?
Is this spontaneous or non-spontaneous? Delta G is a positive 26.59 kilojoules per mole. So is it
Thank
fun?
Non-spontaneous? If it's positive?
That is correct.
Ooh,
So this is one of the easy questions. You just look at it. If it's positive, it's non-spontaneous. If it's negative, it's spontaneous. So do you think K is going to be greater than 1 or less than 1?
It's gonna be less than 1?
Right, because your product side, your numerator would be higher than your denominator. Or your denominator would be higher if it's non-spontaneous. So it'd be like 1/5. So less than 1. So we should predict our answer is less than 1. So let's find out. So our equation, delta G equals negative RT natural log of K. So we can put in our number for delta G. 26.59 kilojoules per mole equals negative. Anybody remember the value for R?
Was it 0.080257?
All right, so we have two R's, 8.3145 joules per Kelvin mole, or 0.082057 liters atmospheres per Kelvin mole. Which R would I use in this problem? Look at the units.
First one,
Which one, Anne Mary?
first one, because it's joules per joules per Kelvin mole.
Okay, good. So this R has joules, Kelvin, and mole. Our delta G is joules, mole. So we want to use the R that has joules in it. Now this one is joules, delta G is kilojoules. So I need to change them both to the same unit. So which one do you want to change?
Would you change the kilojoules per mole to joules?
Kilojoules to joules or joules to kilojoules?
Kilojoules to joules.
All right, so how do I change 26.59 into joules?
Would you divide by 100?
So 26.59 kilojoules, is that equal to 26,590 joules? Or is it equal to 0.02659 joules?
Would it equal 0.02659?
All right, so think of it as 1 kilometer. Is 1 kilometer the same as 1,000 meters? Or is a kilometer the same as 0.001 meters?
Would it be the same as 1,000 meters?
Right, so to go from kilo to meters, you're gonna multiply by,
1,000.
right. So if you're not sure which direction to go, change it to kilojoules and joules, make it kilometers and meters. And it helps you realize, oh, there's 1,000 meters in 1 kilometer. So there should be thousands of joules in a kilojoule. So 29,000 or 26,000 is the same as 26. 26,000 joules is 26 kilojoules. So 26,590 joules per mole equals negative 8.3145 joules per Kelvin mole. Temperature, they tell us the temperature in this problem. We'll assume 25 degrees Celsius. So what is that in Kelvin?
298, I think.
That is correct. So 298 and then natural log of k. So how do I get the natural log of k by itself?
Would you divide the two numbers in both sides?
Right, and then those cancel. So it gives me the natural log of k equals whatever the 26,590 divided by those two numbers, whatever that gives us. I got a negative 10.73. Anybody agree with that?
Yes.
Now, how do I get k? This is natural log of k is negative 10.73. What is k? How do I find k?
Don't you do the E thingy?
Yes, do the e thingy. So I'm going to take e to the x, which is right above my natural log. Whoops. So I got to use second function. So e to the negative 10.73. So e to the negative 10.73 gives me an error. Let's see. Try this negative sign. So I can't use the minus sign. I have to use the minus sign here. So 0.00002. 1879 or 2.1879 times 10 to the negative 1, 2, 3, 4, 5. And that number is definitely smaller than 1, which we predicted, so it should be good. So questions on this problem?
No.
Jennifer? Anne Mary?
No.
Indra and Levi?
No. Oh, we're using two computers now, so
Okay,
kind of like a big TV. So.
sounds good. So 0.000219. And I'll check it. Oh, it did say we were at 298 Kelvin. So that's good. So there's how they did it. Solution. Basically, they solved the equation for natural log of K first, then they put in the numbers. We put the numbers in first, then solve for K, so it doesn't matter. Whatever works best for you. All right, that is pretty much all of chapter 12. So what kind of questions do you have on chapter 12?
I'm working on 13 and I'm a little confused.
All right, we'll take a look at 13. Oh, by the way, tomorrow we are going to be in lab doing some leaching of some copper ores. So meet in the biology room tomorrow. All right, number 12. Use the data to calculate delta G for the reaction described by the equation A plus B yields C. So A plus B yields C. C delta G for A is 387.7. B is 616.9. And C is 402. Right, so here's our reaction. These are the delta G values. So A is 387.7, B 616.9, and C is 402. How do I find delta G for the reaction?
Is it like S plus R or something like that?
Actually, this is only G, so you just have to worry about the G.
Oh.
So just like
Oh.
when it said calculate
H.
delta H, you can just use the values for H or S
Oh, that's a
or
lot.
G. So delta G of the reaction is equal to delta G of products minus delta G of the reactants. So we need to, and because these are all ones, we don't have to multiply by anything. If that was a 2A, you'd have to multiply this by 2. But everything's a 1, so you don't have to worry about it. So add those up. But add them.
1004.6.
And this side is 402. So products are 402. Reactants are 1004.6.
Negative 602.6.
And the units were kilojoules per mole. So negative 602.6. Negative 602.6. All right, it says if delta H and delta S are both negative values, what drives the spontaneous reaction? And in what direction at standard conditions? So is delta G is negative 602. Is this spontaneous or non-spontaneous?
It is non-spontaneous.
So delta G negative. Spontaneous or non-spontaneous?
Spontaneous.
Right, so whenever delta G is negative, we are spontaneous. Now let's look at that equation. Delta G equals delta H minus T delta S. And let's see, what does this problem say? Delta H and delta S are both negative. So delta H is negative. And delta S is negative. So if you have a negative and a positive, which one wins?
Negative.
Negative.
So I could have, for example, negative 5 minus negative 3. What's my answer?
-8. I don't know.
It's negative times a negative.
+8.
So negative 5 plus 3.
2.
There we go. Now let's try a negative 5 minus negative 8. What's your answer going to be?
-3.
Close.
Would it be positive 3?
Okay, which one is spontaneous of those two?
The -2.
So what is driving it to be spontaneous? For it to be spontaneous, I want this part of the equation to be small. When it's small and spontaneous, when that part of the equation is large, like 8, then it becomes non-spontaneous. So temperature, if I increase the temperature, that's going to make this part get larger. So that would make it non-spontaneous if this number gets larger. So at high temperatures, it's going to be non-spontaneous. At small, low temperatures, it's going to be spontaneous. Now let's go back to that question. So is it enthalpy, which is delta H, or entropy driven?
Is it entropy?
So if delta H is negative, is it spontaneous? Says the spontaneous reaction is enthalpy driven to the right. Or the spontaneous reaction is enthalpy driven to the left. So is it going left or right if it's spontaneous? Spontaneous make more products or more reactants?
More reactants?
So more reactant if it's negative?
Yeah.
So maybe you're thinking of equilibrium constant. So delta G, we want it to be negative if it's spontaneous. Delta H will be negative if it's enthalpy. The higher the negative number is, the more exothermic it is. So enthalpy driven is exothermic. So the more negative it is, the more exothermic it is. So when delta G and delta H are negative, it drives the forward reaction. So it'd be spontaneous to the right. But delta S is negative, which is entropy, which means it's going to more order because we're going from disorder to order. So entropy is driven to the left. So it's more entropy driven going to the left. It's more enthalpy driven to the right. So here's I'm not sure if you can see this explanation, but delta G was correct, negative 602.6. But these two are fighting each other. Let me see if I can go back to that other screen. So here we have enthalpy is negative, that makes it spontaneous. So at the small temperature, it's spontaneous. At high temperatures, it was non-spontaneous, which means because delta S was negative, it's trying to make the equation go this way, from right to left, from more ordered to more disordered. So entropy would be spontaneous going the opposite direction. Enthalpy, since it's negative, is to the right. So when delta H is negative, it's forward reaction. When delta S is negative, it's reverse reaction. If they're both, or if delta S is negative and delta S is positive, that means H is positive reaction to the right. If S is positive, that would also be to the right, then that would be always spontaneous. So depending on what your value of H and S are, it's either going to be always spontaneous, spontaneous at different temperatures, or never spontaneous. And delta G tells us whether it's spontaneous or not. If it's negative, it's spontaneous. If delta G is positive, it's not spontaneous. Don't know if that made it more clear or more confusing. All right, we are done for the day. So take a look at your homework, try and get these done. Remember, we are in lab tomorrow, so we'll meet in the biology lab room. Last questions? All right, we will see you tomorrow.